Today I'm in Lowestoft and I'm using the Leica BLK360 scanner to scan this Ex-RNLI lifeboat in order to create a digital model of the boat which can then be used to redesign and refit the interior. This is the Youth 50001 Training Trust, and they are converting this Ex-RNLI lifeboat to be used to train youth in maritime skills. At the moment the boat is a hollow shell, and they're going to use the scan data which we captured today to redesign the interior and fit the boat out for use again. We're using a laser scanner to do this, as it lets us capture accurate data down to 1mm of accuracy. Because the boat has lots of curved surfaces and unusual geometry, measuring it by hand to recreate it in CAD would take weeks or even months of work. However, we can get all this same data in only a few hours of scanning. I set the Leica BLK360 up in the middle of the room which we want to scan, and then it takes anywhere between 40 seconds and a couple of minutes to scan depending on the level of detail that you want. First of all, it rotates around and takes photos with its 3 cameras, creating a 360-degree panoramic image. Then it captures the 3D data, slowly spinning and capturing millions of points in 3D space. So let's take a quick detour and have a look at the device itself. So you can see on the front here we have 3 cameras, and these 3 cameras capture the panoramic images, rotating the device as it goes to capture the full 360 degrees. It then looks at the point cloud and assigns each individual point a colour, based on the colour from this panorama, so you end up with a full colour point cloud. Just below the lower camera we have a thermal sensor, and this captures thermal data, so we can get a heat map of your site and see what temperature different points in your scan were. If we come around to the side here, you can see the mirror in the centre. The laser is projected out of this window in the edge, which you can see just in there, and then bounces off this mirror which rotates on its axis, shooting the laser out in an arc. The body of the device slowly spins as it does this, capturing a full 360 degrees. The scanner can take millions of points in one scan, so you can end up with some really high density and accurate data, with lots of detail in it. For each room we put the scanner in several different locations, which improves the accuracy and allows the scanner to capture data from different angles, meaning that every surface is visible in the final product. As I scan, the data is being uploaded to the Cyclone field app, which I have on my iPad, which allows me to view the point cloud we've created so far and spot any gaps there are in the data. The app also allows me to create links between scans so that all the data can be viewed at once and each station knows where it is in relation to the other stations. The software does all of this automatically, recognising shared data between any 2 scans and then aligns them based on this. We can also add geotags in the app, which are like photos, notes, videos and files which are actually embedded in the 3D space. So this means if someone else is looking at the data at a later date, you can leave notes and things for them in the 3D data. Now that I have done my scans and I'm happy with the data that I have collected, the next job is to take the data into Cyclone Register 360. In Cyclone Register we can edit links and add new ones to further increase the accuracy of our scan, as well as edit the data and remove points that we don't want. Throughout this project I did 49 different scans, which you can see here, capturing all of the rooms on the boat as well as the deck. From each of these points you can view the 360-degree panoramic images, and we can also take measurements and temperature readings. Here you can see the range of the scanner, so we only took scans on the actual deck of the boat itself, but you can see it's got the whole boatyard all around me, which was captured with the scanner's 60-metre range. In Cyclone Register I can tidy up the data, removing unwanted points and cutting the data down to only what I need. Here you can see me selecting some unwanted data with the fence tool and then deleting all the points inside my selection. I can also select the data I want to keep and delete everything outside of this boundary. Now that I have my tidy data, I can export this from Cyclone Register to use. You can take this data into SolidWorks and other CAD packages using Leica's CloudWorks add-on, which lets you model around the point cloud within the CAD package, taking accurate measurements and best fitting objects. Cyclone can also export E57 files and RCP files, as well as many other formats. Using the Leica BLK360 sped up this process a lot. I was able to take the scanner on site and within a few hours have a full digital model of the boat. I joined all the scans in the field app as I went, and then I tidied up the data, removing anything that wasn't needed. I could then send this finished data off to the customer for them to start using to create a CAD model and remodel the boat around.
Now that we're done with the scanning, let me introduce you to Scott Snowling, the founder of the 50001 Youth Training Trust, to tell you a little bit more about what the trust do and how they plan to use this scan data.
50001 Youth Training Trust is a charity based in Lowestoft. We are aiming to preserve and operate the historic lifeboat Rotary Service and to use her as a youth training vessel. Rotary Service is a 50-foot steel Ex-RNLI lifeboat. She was built here in Lowestoft. We're basically refurbishing her on the very boatyard where she was built. On completion of the refurbishment, the Trust is aiming to use Rotary Service to provide a range of RYA qualifications, but also we aim to deliver a range of wider qualifications, including STCW qualifications, which will be more industry approved and recognised in order to be able to provide a good basis for our trainees to seek employment in the offshore sector. One of the big problems that we've faced with the refurbishment is giving people a good, clear image of what the end goal is. The vessel is currently located in a poor location, so we can't bring the public in, we can't sort of demonstrate to them on site the dream, the goal. By using the Leica BLK360, we're able to get a clear digital image of what the vessel is like from bow to stern. We're able to then use 3D CAD to model inside that how we perceive the end goal. That will then also enable us to be able to go out to commercial boat yards with a model of what we want and with technical drawings of what we want, to enable us to get more realistic quotes on how much it's going to cost to have the vessel professionally finished, and that will then enable us to then seek the funds that we need to complete the vessel easier as well. At present, we estimate that it is going to cost around about £200,000 to complete the vessel, and that would be for everything to be complete, up and running, ready for us to turn the key, put to sea and complete the training.